Good evening, everyone. A very beauty line said by Robert Greene that the future belongs to those who learn more skills and combine them in creative ways. So, good evening, everyone. I, Tushar Gujrati, on behalf of Mechanical Engineering Department of SND College of Engineering and Research Center, Yeola, extend a warm welcome to you all to this ATAL Faculty Development Program sponsored by AICT New Delhi. Before we begin today's much awaited session, it is my honor to introduce our esteemed speaker, Mr. Anand Bang sir. Mr. Bang sir is a distinguished academician, consultant, and industry expert with over 23 years of professional experience in design, research, and consultancy. He is the business head and owner of Soft Touch CAD/CAM CAE Jalgaon and has trained more than 10,000 engineering students while guiding over 90 ME projects and 10 PhD research works. He has worked with leading organizations such as Nippon WSP LLC, Japan, Star Coolers and Condensers, UK and India, Ordnance Factory, Warangaon, Emco Transformers Limited, Jain Irrigation Systems Limited, Supreme Industries, and Marico Industries, to name a few. His expertise covers product design, development, R&D, mold design, jigs and fixtures, and advanced CAD/CAM CAE tools. Currently, Mr. Bang serves as a professor of practice at Government College of Engineering, Jalgaon, contributing actively to innovation, entrepreneurship, and industry academia collaborations. We are truly honored to have him with us in this evening. So, ladies and gentlemen, please join me in giving a warm welcome to Mr. Anand Bang sir. Welcome you, sir. Hello. Hello, sir. Am I audible?
Can I audible?
Yes, sir. Yes.
Okay.
You can
Okay.
start session, sir.
Okay. Okay. Is the screen is visible?
Yes, sir.
Okay. Okay. Thank you for giving me this wonderful opportunity in ATAL-FDP program. So the topic is role of AI in robotics. Okay. So now this era of robotics was 5th generation. Okay, now we have seen all over there the autonomous robots and humanoid robots, but there is a history of robots. So first we'll see how the robots was evaluated. Okay, so in the first generation, there are a simple, repetitive and fixed sequence robots manipulators like Unimate. These robots are used for the pickup and place, like a simple task over there. It was a first robot. It was created by Ford Motor and implemented in their plant over there. Okay, so this was the first robot. Uh, in second generation, just one.
Hello, sir. Can you start full screen mode?
Yes, yes, just 1 minute. Now is it visible?
Yes, sir.
Okay. Now in the second era, robots are equipped with the sensors, different sensors and actuators over there. Okay. These robots are used for generally, means like a task like a welding and assembly tasks that this work can be performed by these robots. In the third generation, robots are programmable, okay, in which the robots are self-programmable and operate as per the environment requirement, or they will be able to work with a different programming language. Okay, so
ये छोटा रोटी घेऊन येतो मी ठीक आहे सब्जीचं ते मोठी बनवून टाकतो मी आल्यावर
excuse
हा
me, there is
काय लागतं
someone voice is on.
Hello. Hello, Anand sir. Can you please unmute?
Okay. Is it okay?
Yes, sir.
Okay. So, like in Mahindra, if we check out that.
Hello, sir. You are muted again.
Hello. Hello.
Hello.
Hello. Hello.
Yes, Avinash sir.
Is okay. Is it visible? It is audible?
Yes.
Okay. So if we consider the example of Mahindra, it is a line assembly over there. In that there is a chassis comes on the one conveyor, and it will be assembled by robots, programmable robots. It will be assembled up till the final product. If the product has changed, suppose my vehicle was over there and the different vehicle I want to assemble on that same line, so I have just go for changing the program. Okay, so as per that we can manipulate these robots, the third generation robots, and we can get the alternative work over there. In the fourth generation robots, it is an intelligent robot like manufacturing industry 4, like mobile assemblies industries and different other industries over there, which is being worked on the real time, and advanced logic is really used in this robotics, in this robots. That robots can be work with the human being also, means human labor and your robots are work combinedly. Okay, so it was the fourth generation of robots. Now in fifth generation robots, these are the full autonomous AI robots, or we can call it humanoid robots. Okay, we have seen lot many times there are some humanoid robots are over there. Okay, Sophia or some other robots that we have heard generally. So these are the AI robots. Okay, this is a current stage of development of robotics. Okay, highly sophisticated autonomous robot with the advanced artificial intelligence can be communicate with the human being easily. Okay, these are the benefit of fifth generation robot, and this is a this is a current era of robotics. Okay, now why we use AI in robotics? Okay, so what are the benefits of AI in robotics? Okay, it brings the intelligence in robots, adaptability to do the different functions. Okay, to avoid the human efforts or some work where human cannot be work, like such things over there. So in that case, we can use these types of robot, like space exploration and all, and many other things that we have used. These robots can be make a decision easily by themselves and do the work as per that over there. Okay, if we consider the example of that Amazon, okay, so their warehouse, they have implemented near about 1 lakh robots, okay, for what will be in their warehouse for packaging, for different distribution work. Okay, these robots are work independently. Once you have allotted the task to that robots, and they can work as per the allotted task, and with that they will be communicate with the other robots, so the work will be moved or work will be done smoothly over there. Okay, so this will be the thing, and that is the use of AI in robotics. It will provide that the intelligence to robots over there. Okay, and the benefits that I have mentioned over here, it will enhance its capability. Okay, so whatever the work will be done smoothly with the efficient capacity to avoid the means accidents and all these things. That will be the benefit of that things over there. Increasing the efficiency and productivity by robotics or by AI. We are interpreting the AI with the robotics. So it will be ultimately the goal of reducing the errors and improve the accuracy. Ultimately, it will be affecting on the productivity of the product, and it is improve the safety. Okay, so in that case, there is no human interference over there. So robot can be worked independently with the communicating with each other over there. So it will be safer for the human being. And lot many times there are suppose some mines over there, and there is some hazardous atmosphere, or suppose in industry like painting or somewhat work is over there. In that case, human being also human being cannot be work over there. Okay, so in that case, it will be improvise the safety for human being. Okay, now we'll see that the classification by application of AI powered robot. Now where we use, or where are the applications of this robots in actual use? Okay, so major use of these AI robots in the military, medical robots, space exploration, industrial robot, domestic robot, service robot, entertainment robot, and collaborate robot. Okay, so in that case, majorly the AI robots are used in the military application, medical application, space exploration, and industrial robot. In military application, there are the unmanned ground vehicle, unmanned aerial vehicle, drones, multi-utility leg equipped, then perimeter surveillance robot, modular advanced armed robot system, marine defense robots. Okay, these are the different application in military. Okay, in medical application, there are some robots which is being used for the different purposes over there for the different disease. In that case, if we check out that the nanobot, xenobot, and anthrobots, these are the robots that will be used. We'll discuss how they are work over there. Now, space exploration. We have seen that India was landed on the moon. So we have seen this word, means we are very familiar with these words over there: orbiter, lander, rover. Okay, so these are the AI robots which is communicate. Means suppose we have land the one lander on the that moon land, then rover comes out, that rover will be communicate with the lander, okay, due to the AI, and lander will be communicate with the orbiter, and orbiter will give the signal on Earth. So like that way, they will communicate with each other, and whatever the situation, they will work over there. Okay. Then even humanoid robots, whatever the task in space, like in space station, there are the major requirement of humanoid robot, because the atmosphere over there, or whatever the atmosphere outside the space station, it is very harmful atmosphere for work to human being over there. Instead of that, the humanoid robots are work over there, and some service bots are over there. While if we want to send something to space station or somewhat other places, so, or for maintaining of satellites, which is not possible right now, but by service robot we can maintain the satellites and all these things, that will be possible in future. Okay, so these robots are used in space application. Now some industrial robot, okay, SCARA, articulate robot, cylindrical robot, and delta robot, which is being used for the assembly line or manufacturing purpose. Okay, these are the major use of robots or AI robots in industry. There are some use of robotics in general domestic application also. So if you see that general, there are some vacuum cleaner that will be automatically clean our house, or your machines like cooking machines is over there. These are the basic example of domestic robot which is being used in our day-to-day practice in our house. Okay, service robot is over there. Okay, like suppose a car, AI car is a one type of service robot. You just put the location from where you want to go and where you want to from start location and end location. So it is a one type of service robot. You just hire that car, or this is driverless car. You can enter the location, so it will be drop it over there. Okay, so like this way, that is the application of AI robots over there. Then entertainment robot and cobots. Cobots are work combinedly with each other to do the particular different task over there. Okay, so the future exploding AI robots 14, the defense evolution, more autonomous system with the adaptive learning capability, mission planning and training and execution. Okay, so while we have used the robot in defense, we have seen that there are the different types of robot. Okay, unmanned vehicle is over there, drone is over there. Okay, so suppose if we want to plan some mission over there, okay, so by using AI robots, we can plan that. Means my surveillance robots, or by using drone, we can get a map of that area where we want to execute the mission. So from that, what happened? How much of quantity of enemies over there, which types of systems or which types of weapon they have with them. Okay, so that we can comes to know using these robots. And even these AI robots, or whatever your drone, they will communicate with each other. So in that case, what happened? You will get the map of that area. You will get all the details, what weapon, how many peoples are over there, which kind of things is over there. So you can easily plan for that mission. Okay, and how you have to go over there and how you can execute that mission over there, that you will comes to know from that things over there. Okay, medical environment. Okay, AI robot. Previously, the thing is that if you consider any disease over there, or if any operation is over there, okay, like suppose bypass operation or cancer operation, it was very difficult. Okay, but now AI robot brings the advanced surgical and diagnostic systems over there. Okay, like suppose someone having a cancer. Okay, the cancer is in his brain, or somewhat the cancer is in lungs, so it is difficult to operate that person. In that case, the nanobots is over there. Okay, by using nanobots, simple, these are the nano size robots, so which it can be injected in your body, simple, through a injection. Okay, and they will go to the location of the tumor, and they can remove that tumor easily. One more application that we can consider for the nanobots are over there. If there is a blockage in your arteries or in your veins over there, means if anyone need to go for the bypass surgery, or for your stent is, if you want to put the stent is over there. Okay. If there is a bypass surgery, so that person who has go through that surgery, he can't work for about a 6 month over there. But using this nanobots, it can be easily done over there. Just put the nanobot as per the instruction. Nanobots will go over there. They will remove that blockage over there. Even nanobots is easily deliver the drugs to the particular location. For example, suppose after cancer operation or after removal of cancer tissues, okay, the person has goes for the treatment, further treatment like radiation and chemotherapy over there. While any person has given the chemotherapy, the thing what happened over there, while the chemotherapy will attack, or it will be removing the tumor, remaining tumor tissues from the body. It will also impact on your body cell over there. Okay, whatever your good body cell, with that tumor cell, it will destroy your, means if it will remove supposed to be 10 tumor cell, or it will be destroying 10 tumor cell. With that, it will destroying your 100 good body cells over there. Okay, so drug delivery, in case what happened, so that nanobot will easily deliver the drugs where it is required only. Okay, instead of whole body. While you are given the chemotherapy, it will be translate in your whole body, and it will be reduce your immunity, means your immunity will comes to the 10%. But by this thing, or by this AI robots, which is a nanobots, we can call it nanobots, it will be uh, attacked only, or it will be cover only that particular area. So it will be helpful for the human being over there. Okay. Now in space exploration, AI robots enabling the longer safety human presence on the moon and Mars through the advanced life support and construction capabilities. Okay, so while we are sending the man on moon or somewhat on Mars, so the atmosphere is over there very harsh or very difficult to stay over there. So instead of that, or for somewhat space mission, longer space mission, instead of using a man, we can use the humanoid robots. Okay, so they will do the particular task whatever they assigned to them, and it will be helpful for the human being. Okay, then industrial enhancement. AI industrial robots are more effective for the job that required, which is difficult to the human being, that we have already discussed. It gives you the higher level of precision and good quality and higher productivity. Okay, so because the thing is that human being get tired, that what robots are not get tired. It will be work with 100% capacity at every time. So you will get desired particular quality is good over there. And ultimately the goal is the productivity will increase, because there is no human interface, there is no break, means pause over there in the work. So it will be very beneficial that we have used the industrial robot over there. Okay, now defense and military robots. uh, we see that recently we have seen there are those different types of robots which is being developed. The major development of robotics, or major benefits of robotics in the field of defense is over there. Okay, there are the some robots that unmanned vehicle robots will be help. Suppose some mines is over there on a landfill, so it is difficult, or when your military person is going over there, so it is a chance of blasting that mines. So instead of that, we can use the AI robots, which can be, it can be easily detect that mines in landfill, in your battlefield. So it is not means it is easy to identify, and it is easily destroy, it is easily remove that from the battlefield over there. Okay, then some robots are helpful for the human being over there, like suppose somewhat is injured in the battlefield, so unmanned vehicle will comes go over there and take that person to the medical emergency or whatever. That can be easily done over there. Okay, then where by using the drone, where are the terrorists are located, or where are the their camp, and all these things that can be easily we can find out over there. Okay. Then like China, US, Russia, and India are widely used military AI arms over there. I'll give one example over there that India has recently. This is one Mule robot made by Indian Army, and they have done one mission over there. Okay, that mission was done in Jammu and Kashmir, where these robots are being used for the surveillance purpose. Okay, and these are the AI robots that they can see or they can visualize the in 360-degree over there. Okay, and these robots are being able to communicate with the other robots over there. Even these robots are created the map of the where the that terrorists are located, or where these peoples are located. So the military can easily find out the terrorists and make attack on them and take action on them. Okay, so this can be done easily by Indian Army due to this AI robots. Okay, so these robots that we have seen already, that MULE, multi-utility linked equipment. So these robots are over there. Okay, the Indian Army multi-utility link equipped surveillance robot used for the several AI technology to enable the autonomous and semi-autonomous operations. Okay, so this is be the thing, or this is be the benefit of AI robots. Even there are the drones over there that can be easily make a map of the particular areas over there. Okay, so AI, how the AI will be beneficial in military, that here I have shows in one figure over there. Okay, so drone swarm coordination means if you having a drone, different drones, suppose if you having 5, 50, 100, 30 drones, so that the drone can be communicate and coordinate with each other over there. Okay, signal analysis is over there. Okay, so if the signals are sent by one robot, or one your surveillance robot to another, so that, or your central system over there, so that can be easily analysis over there. Okay, or the signals from other enemy or something, that can be also, they can catch it easily and go to the your uh, stations over there. Okay, there is a object detection and tracking, means suppose if there is any object which is being different than the required over there, or something like machines are over there, or something, suppose weapons are over there, that can be easily detected or tracking over there. Okay, these are the different application of AI, like face recognition, automotive ground vehicle are being very much used over there for providing the foods, for providing the medicines, or providing the health services. So it will be used over there. Okay, then there is a threat assessment. I'll tell one thing over there. Threat assessment is while there is a battle between Israel and that your Gaza. At that time, what Israel has done, what Gaza has done, Gaza, instead of communicating with the mobile, they know that if they are communicating with the mobile, so they can easily catch by Israel over there. So instead of that, they have what they have decided, instead of communicate with the mobile, or either radio frequency or devices, they will decided to use some pagers over there. Okay, and they were put that order to China and Taiwan. Okay, they required, I think at that time they have required 5,000 pagers to communicate with their terrorist or people over there. So instead of that, the Mossad is a agency, that is a agency of Israel. So what they have done, before reaching that pager to the enemy, or before reaching to their Gaza terrorist over there, what they have done, they have put some threads using AI, or there is some short program in that pager and one detonator. It is of about 30 gram over there, and that thread is work with AI over there. So they have put one chip and program it over there. Okay, just means there is no change in that system over there. So that pager will deliver to these people over there. And once they have delivered and when it was distributed to these people, so Mossad, what have done? They have activated that thread over there. And at the same time, all the pager will get burst at a time. Okay, it's a benefit of AI to Israel. Means without firing a single bullet, they have killed about 2,500 enemy at a time. Okay, so that pager will get burst out. Okay, that pager is, suppose it is in somewhat pocket, so it will burst out. It is somewhat in his front, so it was burst out. So all the enemy except the people who has not that pager with them, this if it is supposed to be it is reach of 10, more than 10 meter, so they will get means saved over there, and all the enemies will be killed over there at a time. Okay, so this is a benefit, or this is a capacity of AI. So in the battlefield, not only you can fight with the bullets and all the guns and all this thing, you can fight with the AI also. Okay, and major thing is that we'll see in future further PPTs over there, how that AI will be work in your space mission over there. Okay, so it is also important thing over there. So we'll see in future, or we'll see in next PPT over there. Okay, now use of AI in medical. Okay, that we'll see. So the thing is that there are the different we have seen already that there are the three types of boats over there that we have used in medical field. That first one is your nanobots. Okay, nanobots are what the nanobots has done over there. Okay, so these are the some robot made by the synthetic material, that is used the synthetic material to create this type of boat, and they will program. Okay, so the thing is that as per the program, they are used for delivering the drugs, or they were used for making a small operations over there. Okay, uh, these are used top-down manufacturing system, means there is a one bot will automatically sense the signal or whatever the command that he has received, and as per that the other bots are work with it in a team over there. Okay, the typically the nanobots are from 0.1 to 10 micron. It is very small size of over there. Okay, and measure the area to do the different operations with the robotics, and drug delivery is a major application of this robot over there. Okay, artificial intelligence is a human body. Okay, they are work in human body. Okay, by processing a mass collected by the nanobots in a real time, AI enhance their functioning in drugs delivery, diagnostic, and microsurgery. Okay, so these are used to do the microsurgery, diagnostic the disease or somewhat where the actual problem in body over there. So that can be done over there. Okay, then there was some nanobots is over there. These bots are means whatever the nanobots is made of artificial means it is not it is made of a synthetic material, but whatever the nanobots are, they are made from the proc cell. Okay, so they are make made from the frog cell. So to give that command or give them the instructions, okay, supercomputer is required. This is in a trial phase over there. Okay, so xenobots are, it is means it is not made from the artificial material. It is made up of the tissues of frog. Okay, okay. Is not only design the bots, but it's also refine them through the process similar to the natural selection. Okay, means how, which cells that they have used, or which cell will be evolved in the treatment over there, that you have decide by using the supercomputer. And from that they have used the xenobots over there. Okay, after completion of treatment, okay, once the treatment was over, these robots are automatically destroy itself over there. Okay, so these are not is that much of harmful, or that it will be not that much of complicated thing for the human being using a xenobot for the operations. Okay, then the third one is your anthrobots. Okay, these anthrobots are made up of human cells. Okay, these are made from the human cells. These cells are from your throat on all this thing, taken tiny tissue, and it will be using supercomputer. These tissues are programmed right now. Okay, and it will be used for the treatment of. So these tissues are not need to means after treatment, it is not need to remove, or it is not need to destroy itself for that. It was a self-healing process, means that tissue where that the disease over there, or where that problem is over there in the body, this tissue over there, and auto healing process is over there. So that human being can be cured easily in a very rapid way over there. Okay, so this is be the thing, or this is be the application of AI robots in medical field. Okay, now as we have seen this two field, there is a one more field where the major use of AI robots is space exploration. Now recently you have seen that galactic gearheads robot was developed by some Indian student over there. These students from Institute of Computer Technology, Pune Institute of Computer Technology, PICT. Okay, they have won the robotic challenge that is organized by ISRO. Okay, fly me to mission, fly me to the Mars mission. That is the topic over there. So they want to on the LiDAR sensor. Or LiDAR sensor is a light detecting and ranging is over there. Okay, so means what they have done, they have made one platform that is 50 meter by somewhat 30 meter over there, and they have created that landfill like mass over there. And these whatever they have created a drone, that is a galactic gear. It will be work with the it is having that LiDAR sensor. So using that sensor, it won't needed to control through joystick or control through program. It is that sensor is a AI sensor which can directly detect, or where should he land, from where should he take off. Okay, so these things can be done, even it is not needed to the GPS over there. Okay, so that can be done automatically using AI. Okay, So anatomy of that I mentioned in that PPT. In anatomy, that weight of that drone is 1.7 kg. Okay. Use of optical flow algorithms over there. Okay. This algorithm cannot be means directly hacked through, or it can be means break through any other systems over there. It can be independently work over there. Okay. So this will be the benefit of that. Then computer vision techniques used to analyze depth mapping and identify the safe landing zone, demonstrating the AI capabilities of the system. Means it is automatically take itself decision. It won't require any command over there. Where should he land, or where should he take off, or whatever the things over there, he can take his own decision. Okay, so this is be the things that they have make this drone over there on a Fly Me on Mars challenge over there. Okay, then even India has developing one engine, that Vasimar engine over there. ISRO is developing that engine with one more organization of USA. Okay, so this engine is the it is called as a variable specific impulse magnetoplasma rocket over there. Okay, if you are seeing the rocket, while we launching any rocket, it requires a huge amount of fuel over there. Okay, but in this type of engine, they will use plasma. Okay, which will be accelerate that engine, or which will be accelerate that vehicle over there. Okay, there is a simple gas that can be converted to the plasma. It is one form of the gas over there, and it will be means used for the takeoff of that engine over there. Okay, and it is control means it is enhanced and controlled through the AI over there. Okay, it not required any other things over there. It will automatically make a decision over there. Okay, so there are, if you check out that the it was created means it was a Vasimer engine known for its high specific impulse and flexible thrust module. Means wherever you want, you can reduce its thrust, or wherever you want, you can increase its thrust. It will right now, it is not, it is under the research work over there. Of engine are not only used for the space mission. For this types of engine, or this type of by using this type of engine and robot, the thing one can what one can do. Suppose if there is a satellite, okay, if there is a war is over there, or some problem is over there. Okay, so means the satellite means all countries are use the specific satellite for the communication over there. If you remove the satellite from that particular orbit over there, so that country cannot communicate, or it will be collapse the communication of that particular country. So in that case, these types of robot, if they are in a space over there, they are in a space. So this type of robot can be used easily to defeat any country with to lose their communication system with each other. Okay, so that will be the benefit of that over there. Okay. Then there is one more thing, ASAT. Okay, that lot many countries also developing a ASAT. Okay, so ASAT is a one type of missile over there. Okay, which is being this missile is called as a anti-satellite missile. Okay, the lot many country like India, China, Russia, US has developed this type of satellite. Means to destroy this types of your missile over there. Okay, anti-satellite missile is over there. So this type of missile that can be directly means destroy from ground station to any aircraft, or even in satellite over there. Okay, So use of ASAT is very useful in the future for the condition of war over there. Okay. ASAT can neutralize the enemy satellite using the communication, navigation, and surveillance, dispersing them military operation. Okay. The one drawback of ASAT is what it is over there. So ASAT generate a large amount of orbital debris. Means if it is destroy the satellite, and the rocket will get also destroyed at a time. So at the time of destruction, destroying these things, the lot many part will be revolving in a space over there. Okay, which is being harmful for the other satellite and other devices in the space over there. Okay, so this is be the use of these two things in space over there. Now there is one more thing, that is a humanoid robot over there that can be used for the space exploration mission. Okay, so for the space exploration, NASA has developed one andro humanoid robot that is called as a Robonaut 2. Okay, and even India also work on the same project, that is Vyomitra is over there, which is being used in a space exploration mission. Okay, even suppose in space station, in hazardous environment, if you want to work or some repairing work is over there. Okay, do some scientific experiment in a space. Okay, that can be task is over there. uh, and there is there is a very huge amount of ultraviolet rays which is being harmful for human being. To reduce the risk of human being astronaut, this task can be done easily using this robonaut or Vyomitra can be done over there. Okay, even while you're going for the different space mission like Mars and some other mission over there, so human being, it will take about more than 8 months to reach to the Mars over there. So in that case, it is very difficult to human being to travel that much of time in space. Okay, and it is very harmful due to this ultraviolet rays over there. So in that case, we can use this robonauts or Vyomitra in such types of mission. Okay, even Project ADIN integrate NASA advanced AI system provides the diagnostic support, enabling the astronaut to manage the medical emergencies independently in remove the space environment. Means if anyone needs this medical emergency, in that case, the people who are in the space station or this kind of things is arrives over there. So by using this your robonaut or by Vyomitra, we can provide the facility to them. Okay, this project will be done through the European Space Agency over there for getting these things to come out over there using AI. Okay, now there are some industrial robot which is being regular use over there. Okay, so we have seen the industrial robot, that is Kara robot. Okay, this is a selective compliance assembly robot arm, that is a SCARA robot is over there. Okay, then there is a articulate robots, then there is a cylindrical robot. Articulate robots are work in 6 axis. They can work in a 4, 5, or 6 axis over there. This can be used easily for the assembly line or for the different tasks to work over there. Okay, then there is some delta robots. Okay, these types of robot are being very useful while you're working in the mines or some submarines or some in seas like that. If there is a requirement, these types of robots can be used over there. Now cobots are work combinedly with each other. Means if you've seen some movies over there, like that Rajnikant movie over there, these robots, there are some robots he has developed. They will work in a team. That is a cobots over there. So these kinds of robot will be done combined work over there. If the task is very difficult to work with a single robot. so that all the robots comes together. Means simply we can call it football match played by the robots. I can give the example like that way over there. And mobile industrial robots for transportation or transportation of good, transportation of the different things. The mobile robot are used over there. Okay, so these are the use of robot, industrial robot and AI robots that can be affecting on the productivity, quality, safety, health benefit, and cost saving over there. Initial, no doubt, while you are implementing the robot in organization, the initial cost is very high, but compared to the continuous work, that cost will be saving over there. And some places where you can't work the human, some human can't work at that place, this robot can be work easily over there. Okay. Now, use of AI in a CAD design. Okay. So there is also a being while designing of robot or while designing of any other machines. First of all, we are doing the model using CAD. Now, up till the period, what we have done the modeling using conventional way. But now the AI is also introduced in the CAD field. Okay. So the thing is that previously what the sheet that you have drawn or the old sheet that you have drawn, if you want to convert that sheet into digital format, so the previously what the people has done, they can again draw that sheet in a particular CAD software over there. Then afterward, what happened? There are some software is over there that will be, you can call it raster to vector conversion over there. So first of all, you have to scan that sheet, then import that sheet into that vectorization software. You have to remove the some unwanted data over there. Then there is a process of converting to the digital format. We can call it a digitization things over there. So that can be done using previously. But while we are using AI, just you have to give that drawing to the particular your open source AI software. It will be automatically convert into your CAD drawing. Just an example, if you have suppose if you have taken a photo from your mobile and you will convert that to the PDF format. Okay, it is that much of easy that your means your drawing, whatever, if it is even hand drawn your drawing or it is an old sheet that you're having with you. So just you have to use by using AI, just take a picture of that and that software that can easily convert it that drawing to the your CAD format. Okay. Then there is a automated drafting is over there. In that case, what happened previously, what we have done, we have created a 3D model. And then what the thing we have done using that 3D model, there is a drafting module is over there in every software. Okay. So what we have to do, we have to call that model into drafting. Then we have to generate the views over there. If you want front view, side view, top view, whatever the requirement is over there, we have to generate that view. We have to specify the tolerance and dimension and all these things over there that you have to done over there. And this is be the process. And it is this process is a time consuming use over there. Now by using AI, so automated drafting is over there. Okay. In that case, what we have to do, we have to just mention in your text box in your, even if you can use it chat GPT, you have to provide the particular 3D model over there and just specify what you want. I want just a front view, top view, and side view of that 3D model. Just you have to specify which one from which side you have to consider it as a front view. Then what the thing is that software will gives you automatically, it will generate the views and all this dimensioning and all this done through that AI software over there. Okay. Many of times is what happened. Like suppose I've used to design nut bolts, bearing, or some components which is being similar. Means their family is similar, but size is different. Okay. So in that case, it is difficult to work every time to do that task, or it is a hectic task over there. Okay. So to overcome that, if we hello. Hello, is it okay? Okay, so this task is hectic task. To overcome that, Now in different software like Creo or SolidWorks, the AI tool is introduced over there. So by using this different AI tool, what we can do, we can create a 3D model, and just whatever the requirement we want supposed to be different. Suppose having one bolt, the bolts are from different 10 mm, 12 mm, 14 mm, 18 mm, and the specific length. So I've just put the input what the different model of the bolt I want. So it will take that design and it will be update as per that design over there. So we'll get a number of component over there. And there is whatever if we go for the modeling, it is sometimes what happened uh, due to the human error, the model will get means the model having some error over there due to the human operations. Okay, to overcome that error, AI tool is over there, so it will be helpful for that to detecting that error over there, and it will be easy to means remove the errors and getting a model over there, proper model over there. Okay. Even suppose if I want to design any product, suppose there is I want to design one chair. Okay. So what is my basic requirement of the chair is over there while we are working with the CADs? First of all, I have to specify that requirement. So it should have the moving legs over there. Suppose we having a relaxing chair over there. So in that case, what should I require? It can be rotate over there. It having the hand rest for my putting my hand for the comfort over there. It will have good backrest over there for my comfortability. Okay. So as per this requirement, if I go for creating a model using a conventional CAD method, okay. So once I have designed that model, whether it is being sustaining that load of 80 kg, a person who is sitting on that, it can it be possible to bear that much of load? Can it be means whether it is ergonomically convenient for the human being, or what I have to do? I have to make a changes in that every time. Okay, whatever the feedback data I get, using that feedback data, I have to change it every time over there. Okay, but when we have used the AI in a CAD, so what it has done, it has done the predictive analysis, means whether it is suited or not. That will comes to know while modeling over there. Okay, so that was the benefit of AI. Then you can directly create there is some software by using this software. What you can do, text to the 3D modeling can be possible. Okay, so there are some software which is being used to means creating the model in that way over there. Okay, like Open SCAD is over there. Okay, Draft ID is over there. These kinds of software that we can use to create a text to 3D model. Means you have just specify that, like suppose I want a plate of 100 mm by 100 mm having a thickness of 10 mm. Okay, so that tools is directly create a plate over there which is being of that particular size. You can assign the material over there. You can assign the different parameter, whatever the surface finish, whatever the tolerance you want, by just a texting or by verbally you can command it, so you will get the model using CAD. So the benefit of AI in a CAD, it will saves you a lot many times. It will saves your working hour, which will be affecting on the cost of that product over there. So it is the major benefit of using AI in a CAD application. Okay. Now there are the CNC machine. Nowadays, AI is also used in CNC machine for the different machining. Uh, if you know that, but I'll tell you, I don't know whether you are knowing or not. In the conventional machining, what we have done initially, very first, generally we have to type G codes and M codes to means create a program for CNC machine. Okay, but nowadays what happened actually, there are some software which is like means Delcam or Surfcam or Tebis that can be directly generated the program for CNC machine, and we can put that program to the machine using pen drive. Data transferring system is over there. So any of the medium we can transfer the data to the CNC machine. In conventional machining, what we have to do, there is a specific process over there that first of all, I have to create a CAD model in that software. Okay. Then that software, I can use some translator like IGS or step translator. Then we can translate that IGS, we can convert it that 3D model to the IGS and step. Then we'll import that software into your manufacturing software, like suppose Delcam. Because the thing is that now, if I model in CATIA and if I manufacture or if I create a toolpath using the Delcam, so Delcam use the different backend programming and CATIA use the different backend programming. So it is difficult to directly use the CATIA model in Delcam. So we have to import that IGS or step model in Delcam, or somewhat whatever the SurfCam or Tabis or whatever your manufacturing software, we have to call that model in that software. Over there, even we can convert it to the particular format which is being understood by that particular software over there. Okay. There is some data losses is also over there. Means when you are converting the model, some data loss is over there. So you have to patch that model if it is having any problem. After that, you have to define the workpiece, what kind of workpiece or what size of workpiece you require over there. So as you have specified the workpiece, then you have to define the tools for cutting operations. There are different tools you can use. There are some end mill cutter, bull nose cutter, ball nose cutter. For particular operation, you have to specify the tool for which operation you want, which tools, that you have to define it over there. Then after defining the tools, what will be the depth of cut over there, what will be the speed of cutting, what will be the RPM of the tool, that all the parameter that you have to specify by yourself for machining that particular component. Okay. After providing that, when you have to provide the controller that your machine having, which controller is over there, so you have to specify that controller, then you will get the program from that software. Okay. This program is, again, you have to convert it. This program is in APT format, advanced path for tooling, which is not understand directly by CNC machine. So in that case, what you have to done, you have converted that program to the cutter location file, and then you can feed it to your machine. Okay. This will be the very long process over there. But if I means as AI is introduced in that system over there, so just in OpenAI, even in your Gemini or ChatGPT, you just put the model over there, 3D model. You just put the 3D model and ask to ask to create a CNC program, and whatever the parameters required, means what will be the your block sizes over there, which material of the block is over there, and which kind of tool you having with you. So rest of the thing, it will be generated through that AI program directly. It won't require any manufacturing software over there. It will directly generate the tool, directly generate the G codes and M code, which is being used for the CNC machine over there. Okay, so this will be the benefit. Instead of going for the conventional machining, you can use the CNC machine over there, which is being equipped with the AI over there. Okay. Even the benefit is that no person or no man is required to operate that machine. Just it is required that you have to put the workpiece on the platform over there, and to remove the whatever the mold or whatever the product you have machined, that removes from over there. That will be the requirement is over there, because no programmer needed, no modeler needed at over there. Okay. So directly we can use AI. Nowadays, some machine is equipped with the AI, so that can be used for working this type of work. Okay. Now, there are one more thing that is being available with this CNC machine. In this, some Chinese companies and Taiwan companies, okay, you know that CMM, coordinate measuring machine. Okay. Uh, Now what happened? They have combined these two machine, CMM and CNC, together. Okay. So in that case, what happened? Uh, if you're having a CAD model or 3D model with you, it will not be a problem. If you're having a component with you, or if you want to do the reverse engineering works over there, so in that case, what you have to done? You have to put that component on the platform of the same machine, CMM machine. Okay. So what it will done, it will measure the all the component data is, it will gather that component data is over there. Okay. And from that cloud data, if you won't having any model, it will be one type of reverse engineering is over there. From that data, it will generate a cloud. It will gather the cloud data, and from that cloud data, it will create a 3D model as per your requirement. If you want that same 3D model, you can use that same 3D model for the manufacturing. Or if you want some modification is over there, you can easily done the modification. This thing is being majorly used in Indian automobile over there. Means what they have done, even general practice. Some companies, what they have done, they have take some part from foreign organization, or they have take one part, and internal, all these things are same over there. Just they will change the exterior look of that part, and they will launch that part by their name in India. So like that, they have done these things. Okay. So while CMM and CNC machine is combined, so the benefit is that you no need to go for any modeler or operator. That data will directly get from that CMM. It will take that CMM data. It will create a model over there. Then as you are getting the model, there are the some open AI source applications is with that machine over there. So you have to put the specification, means what you have to do with that product, means which material you have to use, then which kind of mold you want, how many cavity you want in that mold. So just you have to specify the parameters over there. Okay. And the benefit is that afterward it will directly manufacture this object using your CNC machine. Okay. So it will be being majorly used for reverse engineering. Okay. Means whatever the component you have with you, if you want create a number of copies, that can be easily work over there. Okay. Even the accuracy of that product is very good over there. Okay. So in that case, whatever the dimension analysis, whatever the tolerance you require, which is being not getting by the conventional machine, that easily can obtained by your this CNC machine, which is equipped with the CMM. Okay. Even though machine cost, initially the machine cost is comparatively much higher, but in that case, there is no, it won't require any operators. Okay. And whatever the tool part it was generated, that was the optimized one. Okay. Means if a human being is over there, I put some 2 mm depth of cut or 5 mm depth of cut. Okay. That is random. As per my requirement, I'll put that depth of cut. But in that case, it will take a automatically optimized depth of cut if it is required as per the tool and as per the raw material. If the depth is required 1.5 mm, or it is being suitable for the machining, that I have to take a 1.5 mm depth. Okay. So in that case, it will take that much of depth over there. So my tooling cost, major cost is tooling cost. That can be saved in this conditions over there. Okay. Even as consider the safety, means suppose what happens if I want deliver the product is in very short period. So what I have to do while manufacturing that now, so I'll take a higher depth of cut, which is being chance of damaging your spindle, your tool, or your workpiece. So in that case, there is no damaging of tool or no damaging of workpiece or no damaging of anything. So safety purpose, it is very good over there. Okay. So this is with the benefit of your CMM and CNC machine in with AI over there. Okay. Now, still there are some ethical challenge while we are using AI with this all these things over there. Okay. There are the risk of security. Okay. Cyber security risk means there is a chance of your data can be easily hacked or stolen by any other person. Okay. There is no way that you have prevent it over there. Then ethical decision making. Sometimes what happens, anyone asks to that system, AI system, I want this. So it will give its decision, whether it is a fair or whether it is a convenient or not. It will give its decisions over there. Okay. So that is very difficult to take the decision at time. Okay. Then even data security is over there, which is being difficult. There is no moral responsibility. Suppose what the thing is over there. Suppose any work is assigned to any other person. Okay, what he has says, I haven't done anything. AI has done that thing. So there is no moral responsibility while you are using AI. Then unsatisfied action. Suppose if you want ask the AI that I want to do this thing or I want to manufacture this thing, but it will give you something different answer over there. Okay, or it will give something different over there. So there is a lot many times there it is difficult to getting the satisfied result over there. Okay, so this is be the thing. Then responsibility, fairness, these are the things that we can control while we are using the AI over there. Okay, then the AI robotic is transforming our world. Okay, uh, that will create a revolutionary impact on our day-to-day life over there. Okay, that AI-driven robots are fundamentally reshaping the different operations, space exploration, and medical care with the capability that seems impossible just a year ago. Means there is a revolutionary change in our day-to-day life over there by using AI robotics. Okay, life-saving technology that we have already discussed that the nanobots, and anthronobots is over there, which is being used for means doing this things that like operations, then microsurgery and drug delivery that will ease of thing for the human being. Okay, so responsible innovative innovations. Okay, so these are the we can improvise the thing by exploring, innovate, and leads over there. Okay, so everyone, I'll tell that join the AI robotics revolution and help the shape a safety, healthcare, and more connected future for the humanity. Thank you. Okay. So I'll conclude that sessions right now. If you want any questions, please ask me.
All participants, if any question, they may ask now.
Hello, sir.
Yeah.
Sir, what is the cost for CNC machine, including CMM machine? What will be the
That
yeah.
okay. That cost is about more than 2.5 CR right now.
Yeah, okay, 2.5 CR, which combines both the machines. Yeah.
Yeah, yeah.
Yeah.
Even your if you getting a CMM, na, it is cost is about 1 CR is over there, and
Okay.
and it is included with the this AI CNC machine. The cost is about 2.5 CR over there. Right now, this machine is not available in India. These machines are available in Taiwan and China.
Okay, okay, yeah.
Yeah.
Thank you, sir. Thank you. Your session was really nice and informative.
Thank
I'm
you.
Professor Suraj Jagtap from Baramati.
Thank you, sir.
Yes,
Thank
you
you.
been, yeah, yeah. Thank you.
Thank you, sir.
Any other question from audience? लावायचं आहे का आपल्याला? Okay, then. Good evening, ladies and gentlemen. I am Dr. Rani from Mechanical Engineering Department, S&D College of Engineering and Research Center, Evla. It is my honor to have the opportunity to deliver the vote of thanks on behalf of the entire team and everyone present here today. First and foremost, I would like to extend our deepest gratitude to our esteemed guest, Mr. Anand Bang, for his a truly enlightening and thought-provoking address on the topic of AI in robots. Your insights have not only captivated us, but have also provided a clearer perspective on the future that is already unfolding before our eyes. The way you broke down complex concepts from the ethical considerations to the transformative impact of AI on various industries was both accessible and inspiring. You have given us a lot to think about and a valuable foundation for further exploration. We also want to express our sincere appreciation to all the attendees. Your active participation and enthusiasm are what make events like this so successful. A big thank you to the organizing committee members. Thank you, sir. Thank you.
Thank you. Thank you very much.
Participants are requested to stay connected. The next session will be started in 5 minutes. Okay. Am I audible? A very good evening to all present here. It's my pleasure to introduce our respected speaker for today's session, Dr. Avinash Bagul, an accomplished engineer and researcher in the field of mechanical engineering. Dr. Bagul had completed his BE Mechanical from Pillai Institute of Information and Technology, Mumbai in 2012. Later on, in 2014, they had completed post-graduation from KBC North Maharashtra University, Jalgaon, and they was awarded by PhD in mechanical engineering in 2021. He has a rich and diverse experience, having served as a head of the Department of Mechanical Engineering at College of Engineering and Technology, North Maharashtra Knowledge City, Jalgaon, as an associate professor and a PhD supervisor at NES Gangamai College of Engineering, Nagaon. He had also worked as an industrial consultant for WPS Nippon, Japan on ANSYS-based simulation projects. Currently, he is working as assistant manager, design and technical R&D department at Star Coolers and Condensers Private Limited, Jalgaon, where he leads design, analysis, and product development of advanced cooling and refrigeration systems. Dr. Bagul is highly skilled in ANSYS, static, thermal, CFD, and design models, and has published multiple international research papers in reputed journals. He has also executed innovative projects on heat treatments of cutting tools, vibration analysis of gearbox components, and design of submersible pumps, condensers, and freezers. With his extensive blend of academic, industrial, and research expertise, Dr. Avinash Bagul is well positioned to share valuable insights in today's session. So, on behalf of our institute, I request all participants kindly join me in extending a very warm welcome to Dr. Avinash Bagul. Hello, sir.
Thank you, sir.
Sir,
Thank you for welcoming me. Sir, shall we start?
yes, sir. Yes, sir.
Okay, then. I'm presenting my screen right now. Is it visible to everyone, sir?
Yes, sir.
Okay, so welcome all and good evening to the AICT Training and Learning ATAL Academic Innovative session for of 1 week faculty development program on roles of robotics and mechatronics in industry. Today's my session is the 10th session. It's on the robotics application presented by me. So as we know the history, first we discuss about the history, how the robots are developed, and from the where the robot word is occupied. The history of robot is a fascinating journey that stretches from the ancient myths to modern marvels. Here is a structured overview to help you grasp the evolution clearly. From the ancient origin and mythology, Greek myths feature the mechanical beings like Hephaestus, golden handmaiden, and Pygmalion statue, Galacti coming to the light. This is a myth that rumored at the time in ancient times. Since then the same kind of a myth is shared in some Chinese and Indian area. This is Chinese and Indian legends describe automata, mechanical beings that could move or speak, often powered by the water or gears. Then in around 400 BC, Archytas and Tardinat builds the steam-powered wooden pigeon, the first known self-propelled device. I'm going to show you. I'm going to make it big. You can see there. This is the water container where you have to heat, and there is a hollow cavity between this. So once the desired pressure is generated there, and this wooden bird would fly. That's why it's a self-propelled bird. Then pre-industrial innovations. Huh. Statibius of Alexandria in 270 BC created the water clock. You can see here. This is the water clock. They designed the water clocks, which is the moving figures. Early example of self-regulating machines. Then the Antikythera mechanism, which introduced in 100 years BC, was a complex Greek analog computer used to predict the astronomical positions. Here you can see that one. This is what scientists found at the time of digging, and they predict that this might be like this when it manufactured. This is used to calculate the years. Sorry. Then after that, in the time of industrial revolution, in the 19th and 17th centuries, saw the rise of mechanical automata in Europe, clockwork dolls and musical machine. Means they whatever we used to play in the at our early young stage with the self-propelled doll that we used to play after winding the coil in that machines. Then there is an introduction of electricity and motors. With the electricity and motor, the machines become more functional and which pave the way of industrial automation. In 20th century, the word robot was coined in 1920 by Chez Plevricht Karel Capek in RUR, which is the Rossum's Universal Robots, meanings the forced labor, means someone which is forced, someone is forced for the laboring. Then the Mr. Isaac Asimov introduced the three laws of robotics in 1942, shaping ethical discussions around the AI and robotics. Then first robot introduced by the industry, which is useful for the manufacturing. The industrial robots like Unimate begins working in the factory by the 1970, revolutionizing the manufacturing. These are the three laws of the robotics, which is told by the science fictional writer Isaac Asimov. The three laws of robotics, often shortened to be the three laws of Asimov's laws, are a set of the rules devised by science fiction writer Isaac Asimov, which were to be followed by robots in several of his stories. The rules were introduced in his 1942 short story Room Around. Same feature is introduced in the William Smith's movies recently in the I, Robot movie. Those three laws. The first law is a robot may not injure a human being or through inaction allows a human being to come to harm. Means the robot now never allowed it to injure, kill the human being by his action, by his means voice or any kind of the motion. Then a robot must obey the orders given by the humans. Being expert where such orders could be conflict with the first law. Means if human give the order to the robot that to disobey the first law, but this second rule does not allow him to disobey the first law. And the rule third is a robot must protect its own existence as long as as protection does not conflict with the first and second law. Means robot must maintain his existence while working with the humans, but it's not allowed to disobey this first and second law. Then the first ever robo is made, which is not an industrial robo, but this robo is made. There are the pair of robot, which is known as the Elmer and Ilse, which is the electromechanical robots, which is a light sensitive. You can see here the light sensation part. It's a shape like a turtle. This is the transparent cover given. Were the two electronics bots that were built in the late 1940s by the neurobiologist and cyberneticians William Gray Walter. They were the first robots in the history that were programmed to think. Means they think and they move according to the lights. Elmer and Elsie were often labeled as a tortoise because of they were shaped and the manner in which they moved. Means it's a very slow robot, not capable of but they move as per their thinking. They were capable of photoaxis, which is the movement that occurs in response to the light stimulus. Means they respond according to the light behavior. Then this is the history of the industrial robotics. The history of industrial robots began with the George DeWall in 1954 patented the first program article transfer leading to the creation of the ultimate partnership with the Joseph Engelberg, the first industrial robot installed at the General Motor in 1962. This was followed by the rise of the programmable robot in 1980, the introduction of collaborative robots, which is a cobot, in 2000, and advancement in AI and machine learning in 2010, which continues to enhance the robot capabilities and expands their roles in the manufacturing and other sectors. As we discussed in the last session, the robotics with AI. There are some key milestones the robots achieve till date. In 1954, George Dowell is awarded the US patent and they lie the foundation of modern robotics. The Dowell and Joseph Engelberg co-founded Unimation Intercorporation to develop and commercialize Dowell innovations. The first in 1961, the first Unimate industrial robot is installed at the General Motor assembly line, automating tasks like die casting and material handling. In 1960s and 1970s, more companies began manufacturing robots, leading to the development of the more advanced multi-axial robots and the first microprocessor control robots. In 1980s, programmable robots allowed it for the more complex and precise tasks such as the detailing, welding works, and intricate electronics assembly. In 2000, collaborative robots emerged designed to work safely along the human workers. Uh, in 2010, artificial intelligence and machine learning are integrated to the robotic system, further enhancing their capability and ability. So you can see the video here. This is the 1960s video. This is the Unimet robot. This is the Unimet robot, works on the pneumatic motor control and hydraulics. They don't have that much deep electronics. You can see his work and his precision. Sorry. He is doing the precise motions. These are the current robots we use in the industry. You can see there is a lot of manufacturers like Yaskanawa, then ABB, then the Siemens, and they also have a different controllers like Siemens, then Fanuc, and all. And every company contains different controllers. You can see in the first left hand corner there is a orange colored robot, yellow colored robot, and silver color robot. These robots are there. They don't have any kind of the attachment in front of them. You can see, I'm showing you, just wait. You can see here, they don't have any kind of the controller here. Means they are just a robot to perform the motion. But when we attach the attachment, like you can see here, this is for the measurement and quality control. Then this robot becomes the inspection robot. We change that attachment with the suction cup or any kind of a pick and place mechanism. So this will become pick and place robot for the stacking and all. And then this is the different kind of robot. This is the logistic robots. We attach the nozzle of the paint here, so it became the painting robot. So as the connection changes, robot changes its working. The everything is common between these robot. Some at the same time you can see there they all work in each kind of the environment. Just by little protection there in the painting robot, you can see there this is covered due to this is covered with the cloth because the paints particle can damage their bearings and all and the movable parts. So as we covered the industrial robots, the next is the history of medical robots. The history of medical robots began in 1985 with the use of the Puma. Puma is a industrial robot, Puma 560, which is useful for the CT scan guided brain biopsy, where they remove the tissue from the brain by using this Puma robot. This was followed by the development of the robots for prostate surgery in late 1980s, and approval of the robotics for orthopedic procedure in 1990s. The field of revolution revolutionized in 1999 with the introduction of the Da Vinci surgical system, which provides the enhanced control and precision for the minimally invasive surgeries and is still a dominant force in the field. It means the Da Vinci system, which is a dominant in this field of the robotics. In early days, in 1980s, the first surgical robot, Arthrobot, was developed in a Vancouver for orthopedic procedures. The industrial robot Puma was used in a brain biopsy under the CT guidance. Means there is a CT scan guidance, making the first use of the robot on the human patient for a surgical procedure. Late in 1980s, the robot developed at the Imperial College of London was used for the repetitive prostate surgery, demonstrating the potential of the specialized medical robots. The 1990s, the growth and the specialization. In 1992, integrated the surgical system introduced Robodox, a robot for orthopedic surgery, particularly hip arthroplasty. In 1993, the FDA approved the AICTE-1000, a system from computer motion, which held endoscopy for laparoscopy procedures. Then in 1995, Intuitive Surgery Incorporation was founded, building on the robots technology for SRI Internationals. The Da Vinci system, also by Intuitive Surgical, received FDA approval, becoming the first surgical robot to assist the surgeon in laparoscopy procedure. You can see this is the Puma 560 robot, which is used for the first time, and this is the Da Vinci system. Here you can see the Da Vinci system, which is used in the current industrial era, medical era, and this is the Da Vinci system, which can be used remotely. Means the doctor is at the other side and operation is going to be on a other side. This is the first fully functional medical robot video you can see here, making a arthroscopy. The video slightly blurred. This movement of the knee is done by the robot. You can see the robot is a voice controlled. They calling the tool's name, and that robot is giving the tool to the human. Okay, then the current advancement in mechanical robotics. The world first intracontinental remote surgery is recently completed over the 8,000 kilometer, occurred in June 2024, when the Chinese surgeon Professor Zhang Zhu performed a live remote robotics prostate removal on a patient in Beijing, China, while operating from a console in a Rome, Italy. You can see the doctor is operating his consoles, and the surgery is happening in the Beijing. Then the doctor is in Italy at that time. The procedure, which had the latency just 135 milliseconds, was enabled by the 5G network and fiber optics connections, allowing for the near real-time control of robotics arm in China from the Italian capital. The groundbreaking telesurgery event demonstrated for the potential for the expert to extend the specialized care to remote area and is seen as a major step forward minimally invasive surgeries. The key details are: the surgeon is Professor Zhang Zhu, Director of Urology at the People's Librarian Army General Hospital. Location: surgeon in Rome, Italy. Patient in Beijing, China. Date is June 2024. Procedure is a live transcontinental remote robot prostate removal. Technology utilizes a high-speed 5G network and fiber optic connections. A latency achieve a low latency, only 135 milliseconds, ensuring the precision. Significance mark for the world's first successful transcontinental telesurgery, highlighting a new era for the remote and collaborative surgery applications. Then this is also advancement. The world's richest man, Elon Musk, started a company called Neuralink. What he thought is to attach a device in a human's brain, which use his brain signal to communicate with the internet or the computer. So basically, this yesterday what we learn about BCI, brain computer interaction interface. This is the device used for that. Neuralink is conducting a human trial under the PRIMA. Already at 12 people got their surgery and implanted the this Neuralink chip inside their brain. So it's a PRIMA study people with the quadriplegia or ALS. With the first patient, Nolan Arbog successfully demonstrating the thought control computer use after the receiving an implant in early 2024. While early results shows the promise with the users achieving significant hour of daily independent use on record-breaking control speed, some implants electrode threads have retracted, requiring the company intervention to restore the functionality. The company is continuing to recruit for ongoing study and is expanding the research into the into other area like developing a visual prosthetics. You can see the video here. This is a special robot developed for implanting these threads, which place near your neurons. So this is the robot used for that. Then we are moving forward with the military robots. The history of military robots is the history of defense robots began with the remote control device, like in Germany's World War II. Goliath traced the mines, followed by the Cold War's CIA funded aerial vehicles for reconnaissance. Early example includes the World War II Catholic bugs, aerial torpedoes, and Soviet teletanks. These are the robots' name. Modern military robotics have evolved from these precursors with the 2002 war in Afghanistan, making the first use of the ground robot like Hermes in a combat zone for tasks such as the mine detection and cave clearing. Ongoing advancement focus on increasing the autonomy, such as the 2020 incidents where a Kurg drone attacked a human target in Libya, highlighting the complex ethical and strategical consideration of autonomous weapon in autonomous weapon systems. Early concept for the robots and World Wars. In 1898, electrical engineer Nikola Tesla demonstrated the radio control bots for shadowing military uses of remote control devices. In World War I, early remote control vehicles are designed to break trench warfare stalemates. These include the French Schneider's Torpilles Terrestre, a remote controlled demolition device, and American Catering Bug, a prototype aerial torpedo that never saw combat. Then in World War II, the German Goliath trace mines and Soviet teletanks demonstrate the practical use of remote control vehicle for demonstrating and transportation. In the Cold War era, the CIA invested the concept of unmanned aerial vehicles for intelligence gathering and in a dangerous environment. The Firefly drone developed in 1960s and they become the first drone to conduct significant reconnaissance missions. Late 20th century, robot began to use for support and recognizing with the ground robots like Markobot being developed for the tasks such as the bomb disposal. In modern era, in 2000, the Hermes robot, along with other prototype, makes the first use of LT robots in a ground combat in Afghanistan. In 2010, so the military invest in robots increased significantly, developing the continuous on advancement system, including the unmanned aerial vehicle equipped with the missiles and large ground robots with the enhanced mobility. In 2020, Kargut-2 drones from Turkey reportedly attacked a human target in Libya, potentially making the first autonomous lethal engagement by the robot. Right now, the focus shifted to developing the more autonomous and sophisticated defense robots, raising ethical questions about their use in the warfare and increased investment in this rapidly growing sector. You can see there is a drone which works and they're having lots of sensors mounted on that. Some drones having a capacity to go by 70 kilometers. Some drones have capacity to fly over 5,500 kilometers. It depends on the size and what kind of the data what military wants. An unmanned aerial vehicle. Simultaneously, you can see the video here. This is the Mark bot performing the operation. An unmanned aerial vehicle systems, commonly known as a drone, in an aircraft with no human pilot, crew, passenger on board, but rather controlled remotely or is autonomous. UAVs were originally developed through the 20th century for the military mission to dull, dirty and dangerous for the human. And by the 20th century, they had become the essential asset to most military as a control technologies improved the end cost falls. Their uses extend to many non-military applications This includes the aerial photography, area coverage, precision agriculture, forest fire monitoring, river monitoring, environment monitoring, weather observations, policing and surveillance, infrastructure inspections, smuggling, product delivery, entertainment, and drone racing. These are the some kind of the military robots. First is a unmanned aerial vehicle, which uses the some cameras, lidar, infrared cameras to detect the environment and the for capturing the data. Also, they use two missiles. You can see there these two missiles for their protection or the attack. As recently in Operation Sindoor, India attacked by using these kind of drones. They fired the BrahMos missiles on the Pakistani target. Then this is the robot useful for the operation in the sensitive area or the for the rescuing the peoples were attacked by the terrorists or some. This is the dog-like robot which is useful for the imaging, capturing the image or taking the payload to the military base and all. And this is the detonation robot which uses and diffuses the landmines. This is the small surveillance robot you can see there, which is a very tiny, so the enemy is not able to see that robot, and they work as a surveillance robot. These are the current robots you can see. Then the history of the space robots. Space robot traces their lineage to the launch of the first satellite Sputnik 1 in 1957, which marks the beginning of the robotic space exploration. The key development includes the first lunar landing by the robot Luna 9 in 1966, the first interplanetary rover Lunokhod 1 in 1970, and the pioneering the Mars rover Spirits and Opportunity in 2003. Then the second rover is on the Mars is Curiosity, which is a 2011. Humanity foray into the humanoid in space started with the Robonaut 2 in 2011, developed by the NASA, which is sent to the International Space Station. So, in early days, in 1995, Sputnik 1, the Soviet Union Sputnik 1 was the first robotic craft in the space, a simple satellite that orbits the Earth and initiates the space race. Lunar landers in 1960, the Soviet Union's Luna 9 successfully landed on the moon on 1966, followed by the US Surveyor program's robotics lander. Then interplanetary and lunar exploration from 1970s to 1990s. Lunokhod 1, in 1970s, the Soviet Union deployed the Lunokhod 1 rover on the moon, setting the stage for the future planetary rovers. Then the Voyage probe is deployed by the US, which explores the outer planet and continued their journey into the interstellar space. Then Mariner 9 in 1972, the first spacecraft to orbit the Mars. The Mariner 9 mapped the 85% of the Martian surface. Then the Advance rover and the humanoid robots. The Mars exploration rovers in 2023. You can see this is the Spirit rover here, designed by the NASA. The Spirit and the Opportunity rover realizing our understanding of the Mars by analyzing the rocks and searching for sites of the water. Then Curiosity rover, which is a launch on 2011, launched by the NASA. The Courtesy rover continues to explore the Mars, providing the data on the geological and climate. You can see the second photo of the Curiosity rover. Then Robonaut 2. This is the Robonaut 2, first humanoid robot in the space, sent to the ISS International Space Station to test the capability and begin its life in the space. As a torso only unit, they received the legs in 1914. The second version is a torso which get the legs. This is the half humanoid robot. Then ISRO started the working on the Vayomitra. The Indian Space Research Organization is developing the Vayomitra, the female humanoid robots, to support the human space flight, monitor models, and interact with the astronauts. You can see the ISRO's Vayomitra here. So we had some videos. You can see here. This is the video of a Mars Explorer rover, the Spirit and Opportunity. I am fast forwarding because the video is too long. This is how the robotic launch of the the space rover. This is the animation because nobody on the moon to show the robot getting landed. So this is the animation, just it is for the informational purpose. Uh, this satellite contains the rover. Once that satellite comes in the orbit, the second stage is started. Then again it moves for the third stage.
The video is not started.
Sir, actually the video is running right now.
Okay.
Are you able to see, sir?
No, sir. Only screen is there. Video 1, 2, 3.
Okay, I think I might share the different thing. Okay, I am sharing my entire screen. Just wait, sir. I will start the video again. So is it visible right now?
Yes, sir.
Yes, sir. Yes.
So, sir, as the first stage is removed, the satellite is got open. Then it move forward for the another stage separation. Then after getting a velocity, this satellite goes towards the Mars. After 7 months later, the automatically parachute and the protection were deployed. This is the landing of the first ever the robot Spirit, and what the satellite that takes here is an opportunity. That's why it's called as a Spirit and opportunity. This robot is used to explore the Mars for the what the chemical compositions and what the minerals are there, and also the water is there a water present in this past presence references for the on the Mars. This video is issued by the NASA. From there, it started its journey. I am forwarding that. Here you can see this robot analyzing the Mars surface. This video is given by the NASA, which is available on the YouTube on the NASA channel. There is the ultrascopy, which is used for the analyzing what are the contents means in the in that rocks, what are the minerals are there. Generally, ultrascopy is used in industry for analyzing the chemical composition of metals and sheet metals and all. Okay, sir. Then I am sharing a second video with you. Which is the Chandrayaan's landing video. Is it visible, sir?
Yes, sir.
This is the landing of Chandrayaan 3, which we already might seen on the television. This is how Chandrayaan works and how he goes there, how he is landing, how he project himself, project himself to land safely. Then this is the Chandrayaan rover, and this is their cabin. Chandrayaan scans the data available. These are the parts of Chandrayaan. This is the live telecast. Is showing when the separation of rocket stage and by the ISRO, the people. So I'm sharing another second video of courtesy rover. Hello. So there is a background noise there. Hello.
Yes, sir.
I'm sharing the second video also, sir, right now. This is the landing of the Curiosity rover. I have fast forwarded here. This is the Curiosity robot by the NASA on the space on the Mars. This robot sends the pictures to the NASA of the Mars. This rover also have the high quality of sensors for analyzing and studying the Mars. So I'm switching off that video also right now. These are the space robots. What we are using in our system, I'm going to show you. So this is the robot we use in our factory at the Star Coolers. You can see this is the welding robot. You can see there is a joint. We manufacture actually the heat exchanger that requires the circuiting, means the looping of the liquid refrigerant or the or cooling media and so and all. So we have to introduce the fin inside this over these tubes, and after insertion of the fins, we require to expand that tube. After expansion, we have to connect the these tubes by using this bend, while using a U bend, C bend, as per the circuiting given by the customer or which is suggested by our application. We had a four boards. You can see these four boards which is used for the welding. They automatically adjust the argon pressure, then the current as per the chemical composition of this uh, tube material. You can see uh, this is the locking mechanism. There are the sensors, chilling medium and all. Once it started, you can see the dial here. What I zoom. This started the welding over the tube area. This is the starting phase. Then this is the secondary phase. This is the welding and joining of the two metal without any kind of and this joint is completely sealed without any kind of the problem. We used to check our tubes at the 400 psi pressures. that much precision is required. So this is the completion of the welding. Also, we had a second robot uses for the bigger pipe joining. Are you able to see the video, sir?
Yes, sir. Yes, sir.
Yeah, we uses this kind of robot for the header welding. Means these tubes are connected to the single pipe, which is a bigger, and we require to close the one end, and we have to open the one end for the refrigeration inlet and outlet. So we uses this kind of the robot. These two robots are present at our factory. Then I had some videos about the BMW car manufacturing. You can see here. These are the robots used in the industry. This one is the pick and place robot. This robot is used for the bolting of with the hinges of this bonnet. Okay, this robot uses a fastening robot. This video is also too longer, which takes about 15 minutes. This is the deionization of the sheet metal or the any plastic parts, because this is not allowed to ionize charge ionize while using the electronics. At some point I will fast forward this video. You can see the pick and place robot, which places the sheet, and as well as also the second robot uses to lift the form structure form or the sheet metal form. Here you can see the welding robots, they are joining. In some industry they uses the welding, some industry uses the riveting, some industry uses the riveting, some industry uses the spot welding also. Even in right now condition, some uses the sheet metal joining glue or the sheet metal joining adhesives. You can see they are the industrial, as they are the industrial robots. They required their only working area. There no human is allowed here. Then the fencing is completed there behind these robots for their working. They are guarded with the fence, so no human can be harmed by these robots. Here you can see this applying the sealant and as well as the sheet metal glue. This robot precisely applying the sheet metal glue. Then this process is completed. These are the spot welding robots. You can see the two ends of the spot welding. Once operation is done, they goes to their home position and the fixture is removed. As in assembly line, I am moving forward. Some parts. Here you can see the fastener robot. They mount the hood This is the electrical vehicle. You can see the battery pack there. That's why that deionization work already completed, which we saw earlier. I'm just fast forwarding it. This is the engine scanning. They manufacturing the engine by the robots. They scanning the engine, which is perfect or not. This is the 7 tank deep process, which helps which helps to maintain the sheet metal according to any kind of the environment, and also gives the better finish for the coloring. You can see there are the coloring robots. They apply the even coat in this area. These robots save the paints. Each robot have given the specific area. I'm powdering slightly. This is the measuring robot. They are measuring the quality of the product. You can see there are the logistical robots which transport the dashboard of the vehicle whenever required. They are working autonomously. They work on the sensor-based interface to communicate with each other and communicating with the assembly line, which part is going to be required and when it's going to be required. These automatically adjust the position of engine mounting. This is the unitation of powertrain and the body of the vehicle. In the industrial language, in the automobile language, they call it the marriage, because here the body gets the power from the powertrain and it's complete the vehicle. This is quality checking of the vehicle and so on. So this is the BMW's report. Recently, our PM, Honorable Narendra Modi ji, visited the Gujarat Science City, which is the where they completed the Gujarat Robotics Gallery. You can see these are the humanoid robots, the toy robots, 3D printers, servo robots. These are toy robots also, as well as all-terrain robots, useful for the defense as well as the home uses. This is a climbing robot, surgery robots, home domestic uses robots, industrial robots. Many of the robots are there. I'm going to show you the precision of this precision of the medical robots. Like this, you can see. This is the Da Vinci system, what we already discussed. The operator is on that side and he is doing a surgery on this side. This is so precise that he is peeling a grape right now. This is the beauty of the precision work and the engineering. So thank you. This is from my side, sir.
Okay. So participants, if you have any query, you can ask.
Hello, sir.
Yes, sir.
Yes, sir.
Sir, if possible, will you share please videos that you shared with NASA?
So I think that's all are available on the internet, but I will share these videos with the coordinator.
Okay.
So you can contact him and get the video.
Okay, sir. Thank you.
Yes, sir. Actually, we are uploading this all session videos and audio जो meeting we have recorded in the meeting. We are going to upload this on our college YouTube channel so that everyone can take it and see the videos of this session.
Okay. Okay, sir. Thank you.
We will upload all links, sir, that we are already provided by resource persons. Anyone? So I appreciate the opportunity to extend a sincere vote of thanks to Dr. Avinash Bagul for his insightful and engaging session on robot applications during our faculty development program. Dr. Bagul, your expertise in this field is evident, and your ability to simplify complex concepts and provide practical examples made this session both informative and highly accessible. The applications you discussed, from industrial automation to medical robotics, open our eyes to the vast potential and ongoing evolution of this technology. Your presentation was masterful blend of theory and real world relevance, which is precisely what we hope to achieve with this FDP. We are truly grateful for the time and effort you invested in preparing and delivering this session. Your passion for robotics is infectious, and you have undoubtedly inspired many of us to integrate these cutting edge topics into our own teaching and research. Thank you once again for sharing your valuable knowledge and for making our FDP as a resounding success. We look. Thank you, sir.
Okay, thank you, sir. I also like to thank Jagdamba Education Society for giving me this opportunity. Also to Principal Dr. D.M. Yadav sir, FDP coordinator Dr. Harjit Pawar sir, and also like to thank Dr. Harshal Rane sir for giving me this opportunity and express my vision and the thoughts with all the faculty members. Also like to thank to the faculty who joined this FDP program to listening and having a good session with you. Thank you, sir.
Okay, thank you, sir. Participants are requested to fill the feedback. The feedback link we will be providing in the chat box. तुम्ही टाकले का मला? हा, उद्या तिसरं टाका. तुम्ही ते लिहिलेलं ते. तिन्ही D6 D5 ची टाकली ना वरती. आहे का? The feedback link is available in the chat box. All participants are requested to please fill the feedback. And tomorrow we're going to start 3 sessions. So on tomorrow, the session is started on 2 p.m. So all participants kindly note, tomorrow's session will be started from 2 p.m. Indian Standard Time. And there is online test in the range between 6:30 p.m. to 7:30 p.m. After that, after 7:30 p.m., we are going to the valedictory function of this event. Thank you.